Welcome to this Getting Started guide for UKCloud's cloud-native infrastructure powered by OpenStack. We're going to take you through everything you need to know to take a completely new provisioned project, deploy instances and start connecting it to the internet and serving applications. First thing we want to do is log into your environment. You'll have been provided with a username and password credentials to log into the cloud-native infrastructure. You should have also been sent the URL to connect through. So enter the credentials into the login screen and we click connect. The very first screen you come to gives you a quick summary of where your resource usage is against quotas. Each project is set up with a standard set of quotas. If you feel that you need to go over those quotas, then you need to raise a service request, and there's soft limits which can be easily updated by our support engineers. Before we can start launching instances, there's a couple of housekeeping things we need to prepare and set up in order to launch instances. The first thing we need to do is create an SSH key pair. Now you may already have SSH credentials from the existing infrastructure you manage. If so, you can fast forward a couple of minutes. Otherwise, I'll show you how to go about creating them. Typically in a Windows environment, you don't have your standard OpenSSH tools available. One of the more common and favourite applications people use in a Windows environment to use SSH connections is PuTTY. We're going to use PuTTY and in particular the PuTTY Gen application to create our SSH pairs. So if I do start and run from my Windows environment here, run the application called PuTTY Gen, and that will give us a window to start generating our SSH keys. I'll click the generate button. Now the PuTTY Gen asks you to move the mouse around randomly in this area, and it uses the randomness to generate your SSH key. When the green bar gets to the end, we'll have our SSH key. Now you can customize the comment here. I'll just leave it as standard for the moment. It's also recommended to put a passphrase on your SSH key. I'll very quickly put a password on here. This password will be used to unlock the key each time you use the private key to authenticate with the server. And given that's then your secure method on the servers, we'll recommend putting a password on there. We now save the private key, and this will save the file in a PuTTY format with a .ppk file extension. Remember where we save it because we'll need to use it later. The other part of this we need is the public key pair in the OpenSSH format. We see this lot here. I'm going to copy everything in this top window. Make sure we scroll all the way down to the bottom. Copy that window. And now we're going to flip back over to our OpenStack project. So go to the Access and Security menu on the left. Find the SSH pairs tab up the top here, and we're going to import an existing key pair. The public key is what we just copied. I'm going to paste into this window and give it a name. Let's call it my key pair. You see here on the right hand side are the commands that you might use for on a Linux or a Mac workstation where you have the OpenSSH tools available, and is the equivalent to what we've just done with PuTTY in terms of generating a key. So I'll click import. Within a few seconds we can see our public component of the SSH key has been uploaded into our OpenStack environment. Now the next thing we need to do before we can start launching instances is define our security groups. The security group is your boundary firewall around each individual instance. When the project's first delivered, you'll have a default security group. This security group cannot be deleted, and usually people just leave it alone and create additional ones as needed. So I'm going to create a new security group. I'm going to call it external SSH because I want to allow SSH in from external sources. Okay, So that's now defining our security group. What we need to do now is manage the rules in that security group. So we click on the button at the end. By default, you'll have two egress rules defined, one for IPv4 and the second one for IPv6. Now we don't actually have an IPv6 environment, so you can safely delete that rule. We don't need that one. Now we want to add our own custom rules. So there's an add rule button here, and the drop down gives you the more common standard rules that you might want to allow. If I scroll down this window, we've got SSH at the bottom. You'll notice it changes the fields accordingly if you use one of the predefined rules. Now, because I want to allow a connection from anywhere, I'm going to leave the site address as the standard 0.0.0.0. We'll look at some of the other options in a minute. I'll click on Add, and that's been updated now with port 22, which is the SSH port. I'm going to add a second rule to allow ICMP, so we can ping our interface, our instance, when we bring them up. This time I'll just say all ICMP. And again, I'll leave the source as being open to everything. That will do for now. So we've now got an SSH key, we've got a security group. Next thing we need to do is sort out our network infrastructure. So if we go to the Network tab here, there's two different ways you can go through this. I'm going to show you the network topology screen because it gives us a nice, easy place to do everything else from as part of this session. All you'll have provisioned initially is one external network in the middle. If we click the toggle labels, we'll see that it's called Internet. Now, you may have been provisioned a project which has connectivity to other networks such as PSMP, N3 or Janet. They will also show up using this little world logo to represent an external network. So the first thing we want to do is create a router that's going to connect to that external network. I'm just going to give it a name. We'll select the external network, there is only one to choose from, and click Create. And here we go, we've got a router connected with a line through to our internet. Now we're going to create an internal network. So we've got the button up here to create a network. Let's call this DMZ. We're going to follow the next style wizard buttons, which will take us on to define the subnet within our network. We can define a subnet address using standard CIDR notation. You can use any network range. I'm going to use 10.0.0.0/24. And we're going to define the gateway IP address on that network as 10.0.0.1. Click Next, and we can then look at some of the options that will be used for DHCP. The only one you have to specify is DNS, because otherwise your servers won't know how to resolve host names. You can optionally specify an allocation pool. If you leave this blank, then OpenStack will use the whole of your CIDR subnet minus the gateway IP address and allocate addresses from within that range. You can be a bit more specific, and in this case I'm going to use a smaller range which leaves some IP addresses at either end of that range, so I can statically assign some virtual IP addresses or otherwise. For now, I'm just going to use standard Google 8.8.8.8 for DNS, and we click on Create. Okay, now we've got a separate network here, but what we need to do is connect it up to our router. The easiest way to do that is we click on the router device, click on Add Interface, and then from the drop down here we'll see our newly created network and subnet. We don't need to specify an IP address because when we defined the network we specified what the gateway was going to be. We just click on Submit. And there we have our connection coming through from our DMZ network to our router, connecting throughout the internet. We now have all the pieces in play, so we can actually start creating instances. Now we can do that from this screen, or we can do it from a number of other places. I'm going to show you what the options are here. Go to the Compute menu. We could also go to the Images screen. Now we provide a number of standard images as part of a public catalogue. You're free to upload your own images as well. If you upload your own, they'll appear under the Project tab here. We've got 15 we can choose from. So we've got CentOS, we've got Debian, CoreOS if you're running containers, Ubuntu. I'm going to choose a CentOS 7 image for here. And again, you could click Launch at the end of this screen, or you could go to the Instances menu on the left here, and we can launch instances from here. So I'm going to do Launch Instance. First of all, I'm going to give the instance a name. I'll call this one Demo. When you're launching your instance, you have a choice of failure domains or availability zones. So when you're architecting a solution, you can choose to place your instances in either zone C1 or zone C2. I'm going to leave it as zone C1. This allows you to build out clusters where you can guarantee that each pair of your cluster, maybe a master-slave database pair or whatever, can be architected and be guaranteed to be on different physical hypervisors, different underlying hardware. For the moment, I'm just doing a single instance, so we don't really mind. We're going to go on to Next, which will take us onto the Source tab. And this is where we can then select what image we're going to boot from. So I'm going to select our CentOS 7 image. And we can see it's now listed up here. We have other options for booting. We could boot from a snapshot, or we could boot from a volume. If we just take the option as it is, what will happen is we will boot up an instance. It will copy that CentOS disk image onto the ephemeral disk on the hypervisor where our instance is going to boot up from. That ephemeral disk, you've got a 60 gigabyte allocation. That's it. If you're going to need more than 60 gigabyte, or indeed if you're going to be storing data which needs to be persistent, then you might want to look at creating a volume. And there's a quick way of creating a volume from the menu here as well. And you can specify what size disk you want to be created. So I'm just going to say 10 gigabyte. If it's data you want kept, you probably want to leave the default on this delete volume as no. I'm going to say yes, just because it will make sure it's cleaned up afterwards. So that if I delete the instance, the volume that we're going to create will also be removed. We go on to the next screen now, which is the flavors, and this is where we define how much RAM, how many CPUs our instance is going to use. I'm just going to choose a small one here. You'll notice the top one has a little warning symbol by it. That's because we selected the CentOS image, and that CentOS image knows that it has a minimum requirement. So I cannot choose the T1 Nano to launch this instance because it will not allow me to. So I'm going to choose the next smallest one, the T1 Tiny, again clicking the plus button. I'll move on to the next screen. We can then select the network we're going to attach to. We've only created one network here, but you might have created multiple networks, and you can choose which network to attach to. We haven't done any network ports because this is a very simple example, so there's nothing to choose from on the next screen. Then we move on to security groups, and this is where we can select the security group we previously created. Moving on, we've got the key pairs. Here's our SSH key pair that we previously uploaded. The last two options on the side here, we don't need to worry about for now, but customization script gives you the opportunity to upload a shell script or a set of commands and configurations which will further customize your instance when it boots. The metadata allows you to set up various tags, which is just metadata which you can use yourself for reporting, for grouping the instances, for finding them later. I'm going to click the launch button now, and it's going to go away and do its thing. Because we've chosen to launch this instance using volume storage, the persistent storage, the first thing it's doing is creating that volume. If I click on the Volumes tab now on the left-hand side here, we'll see that it's currently downloading the image to our new 10 gigabyte volume. You'll notice that here it's also got type of tier 2. We have two different levels of storage available to our OpenStack infrastructure. Tier 1 is fast, pure SSD based disk arrays. Tier 2 is a slightly slower SAS type storage, which costs a few pennies less in terms of the cost per gigabyte. The default when you go through the launch instance menu that we've just chosen is it will default you to using a tier 2 slower, cheaper storage. If you need to have your instance booting off the faster tier 1 storage, you can do that through this menu, and I'll follow that up as another subject later. If we go back to the instance menu, we'll see now that we've created our volume and that instance is now booting and it's running from that menu. That's great, so we've now got an instance running. If I go back to our network topology view, we'll see that instance hanging off our DMZ network. And here it is. From here, if you click on the instance, you can even open up the console, which will give you a VNC view and it'll show you that the instance has indeed booted and we've got a logon prompt. Now, because we're logging in with an SSH key, there isn't a password set by default for you to be able to log in from the console. So it's not going to help initially booting, but one of the things you might set in your customization script is a default root password, which would allow you to log in through the console. Now, in order to connect now, what we need to do is associate a floating IP address to that instance. I'm going to go back to the instances menu now. From the right-hand side of the line that we're interested in, we've got a drop-down menu. And from here, we can do a number of actions with our instance, from stopping them, from rebooting them. You can even pause and suspend them. You can edit the security groups, and we'll have a look at that option in a minute. But the one we're going to look at here is associate floating IP address. The floating IP address is what sets up your destination NAT for inbound connections that will allow connection coming from the internet or from whatever external network you're connecting your project to and route that traffic through to your specified instance. Before you can select a floating IP address, you see there aren't any here yet, we have to actually allocate one to our project. You can handily do that with this plus button on the same screen. Now there is a quota. Each project has 3 floating IP addresses allocated, or quota of 3 IP addresses. It won't allow you to create more than that. However, if you do need more, again, it's a service request, put a call through the My Calls in the portal and specify you need to have more IP addresses. I believe they are allocated in the blocks of further 5 and 13. So we've selected the internet, the only one available to us. Click on Allocate IP Address. From the point that the IP address is allocated, it is yours, it is tied to the project. It will not get reused by anyone else. You can set up firewall rules and whatever you need to, knowing that this address has been allocated to your project. However, you can move that IP address, the floating IP address, around any of your instances. So for the moment, we're going to associate it with our demo instance. But in the future, you might have another instance you want to associate that floating IP address to. And that's fine. The actual external IP address will still be yours and yours alone. But you can point that and have the destination NAT rules changed to go to any internal instance. So here we go. We've now got an external IP address associated with our demo instance. I'm going to copy that IP address, and this time I'm going to run putty. And this is our SSH client on Windows. I'm going to paste in that IP address. And down under the SSH menu, under Auth, we want to then browse and find that private key that we saved earlier. This private key needs to match up with the public key that we told OpenStack to launch the instance with. If we click on Open, we should now we'll have a prompt saying, is this correct? This is the identifier for the instance. So I'm just going to say yes. And it'll give you a login prompt. Now, different OS flavors will use a different default username. Because we've launched a CentOS instance, the username we need to log in with is CentOS. If you're launching a Ubuntu instance, then you'd log in with an Ubuntu user. That should use our SSH key that we've configured and log us in straight through to a command prompt. After prompting for the passphrase for our SSH key. And there we go, we've now logged in. And here's our IP address, it matches up 10.0.0.53. That matches up with what OpenStack tells us we've got. And there we have it. You've now successfully launched your first instance running on the UKCloud cloud native infrastructure powered by OpenStack.